All right. So basically, you need to remember this as being the mean value theorem. Okay? All right. Now, what does it mean? No pun intended there. All right. What it means, wow, guys. What it means is that you have a line right here. This is the secant line because it goes to A, f of A, that's the ordered pair, and B, comma, f of B, whatever this function in blue is. That's how you get those values. That has a secant, that has a certain value of a slope, and so does this value. And notice, what are they to each other? They are parallel. The tangent line is parallel to the secant line because that's the only way they would be having the same slope. Okay? And your job typically is to find that C that occurs. That's the only place. There may be more than one place, depending on the function, but if you have a continuous function and differentiable everywhere on that interval, you are going to have at least one value. Okay? All right, so let's basically remember the average rate of change is the same as the secant line slope. We had the average rate of change early in chapter 2. Okay? The instantaneous rate of change is the tangent line slope. Okay? So basically we're saying that they're the same. Okay? That's just different language. All right, so let's try one, and they're not always going to call it X. They're kind of called whatever they're going to call it, but that's the C value from the mean value theorem. Okay, at what X value on the interval -2 to 3 does f of X, that's your function, f of X equals x squared plus 2x minus 1, satisfy the mean value theorem? Okay, so this is -2. I already put the dot on -2 and 3 something. Okay, so draw yourself a secant line between -2 and 3. Your secant line. Okay, now just we can guess it, but draw yourself a tangent line that's going to be parallel to that secant line that goes through the function. So you could clone, I guess I'm going to clone. Clone this and move it. It looks like it's about right there. Those are parallel. Okay? So it looks like, we're going to do this analytically, but it looks like my C value might be about right here. Okay? I'm not sure if it'll do this.
How do you determine where your C value is?
The C value is, we're going to find it using our calculator, but the C value right here looks like it is right here, and that's the point where it's going to be tangent to this line. It goes through C. Okay, so mean value theorem says f prime of C equals f of B minus f of A over B minus A. All right, let's determine, first of all, I guess, what's A and B? That's right. A and B is right here. So I'm just going to fill this in. F of 3 minus f of -2 over 3 minus a -2. All right. I'm just going to keep going here. How would we figure out what f of 3 is? Plug 3 in the f function. 3 squared plus 2 times 3 minus 1. 9 plus 6 minus 1 equals 14. That goes there. F of -2, same thing, except this time put in a -2. Instead of the 3. All right. So what do we get for the f of -2? -1. That's a +4. That's a -6. I don't think it's -1.
Yeah, you can -3.
Well, let's just do that right then. Thank you. -2. All right. So 4. It is. You're right, Hannah. It is -4. Okay. Good job. All right. And then we have what on the bottom? 5. All right. Let's keep going. One more step. What is that? 3. Okay. So what does that mean to this figure? That's the slope of this right here. Yes. So now we want to figure out where the C value is that has a slope of 3. So how do we figure out what f prime of C is? First of all, I guess we need to figure out what f prime is. What's f prime? Anna?
2x plus 2.
2x plus 2. So what's f prime of C? Because that's what it says right here.
1/2.
No. 2 C plus 2. Remember, that's the same thing we did down here when we figured out the f of 3, except this is f prime of C. C goes in for x.
You put 2c plus c.
I put 2 C plus 2 in there, yeah.
So is c just the value we just found?
We haven't found C yet.
No.
We are about to, because we have an easy little equation to find C, right? So 2C equals, and C equals 1/2, which is pretty close to where we thought it was going to be. Okay? It's a very specific theorem. I'm not sure that it's that important, but it is. We don't have that many, so. Okay, they're not always going to give away that we're using the mean value theorem, but they may say, where's the secant line slope the same as the tangent line slope? That would be another way of saying, use the mean value theorem. Any questions on what we did? I just worked one side, then you worked the other side, then you put them equal to each other. But this is the piece that you'll want to remember is the mean value theorem, assuming you have continuous and differential function. Okay? All right. We did that already, right? So we're good. All right, let's go back and look at answers. Okay. Let's see, we're doing 7 through 11, right? All right. So how long did you stay in Boston? How long did you stay in Boston?